1 minute.
Just you can able to have a trial, but screen is sharing or not, you just check it once, because Ravindra is telling. Just you can check once.
Just go to present screen share option, sir. At the bottom. At the bottom in the meet.
I guess now
Yes,
you're able to see my screen.
Yes, sir, we are getting. Yes.
Correct.
Yes, sir.
Correct, you are sharing the screen.
Yes, visible, sir?
Now you minimize it, this meet window, sir, and go to your presentations window, sir. Minimize this meet. And then go to the folder or file of your PPT or video.
That's what Ravindra, they are doing it.
Yes,
No problem. They are doing it.
Fine.
Ravindra?
మ్యూట్ చేసేసారు సార్, మ్యూట్ చేసేసాను సార్. మీకు ఒకసారి పీపీటీ కనిపిస్తుంది.
Sir, Ravindra sir, is my voice is clear, sir?
Okay, sir.
Where it is clear?
Sir, it's clear, sir.
Yes,
Okay, sir. Thank you, sir.
Okay, now everything okay, sir. So this, sir.
Okay, thank you, sir.
HOD, sir. Sir?
Madam, Amrita, madam.
Sir, I should start, sir.
Madam, 10-5, madam. You 5 minutes
Okay, sir.
buffer and 10-5.
Okay, sir.
Okay.
Okay, sure, sir. Speaker out, sir.
Madhura, madam. Madhura, madam.
Sir.
Madam, Yagunarayan madam join అయ్యారు మేడం.
లేదు సార్, చెక్ చేస్తాను సార్.
ఒకసారి నేను కాల్ చేస్తానండి మేడం, నేను కాల్ చేస్తాను.
1:30కి జాయిన్ అవుతానన్నారు సార్ ఆఫ్టర్నూన్.
ఓకే, అది వాయిస్ క్లియర్ ఉందా మేడం? మేడంది
ఉంది సార్, నేను ట్రైల్ చేశాను సార్ మళ్ళీ నైట్.
జాయిన్ అయితే ఒకసారి ఇప్పుడు కూడా ఒకసారి జాయిన్ అయ్యి క్లోజ్ అయిపోమని చెప్తాలేండి మేడం, నేను సో దట్ షుడ్ బి వెరీ క్లియర్. బిజీ ఉంటే ఓకే, లేకపోతే
లీవ్ పెడతానన్నారు సార్ మేడం.
సార్ నేను కనుక్కుంటాను. ఐ జస్ట్ కాల్.
ఓకే ఓకే.
ఇది హెడ్సెట్ పెట్టేస్తా. హెడ్సెట్ పెట్టేస్తా.
Good morning, madam. Okay, madam. Madam, can you join, madam? If you want, you can just join and see now. Not just just to confirm, mobile also can just join it so that you can confirm, and then afternoon 2 o'clock we will start the session. Okay. So 5 minutes to start. Okay.
Thank you.
Sir, shall I start, sir? HOD, sir. మేడం వెయిట్ మేడం, సార్ చెప్తారులేండి మేడం.
2 minutes, madam. I'll just confirm for madam, madam, and I'll come back to you.
ఓకే సార్.
One of the participant has started sharing. Please mute that sharing.
Kamartaj madam,
Yes, sir.
ready na madam?
Yes, sir. Yes, sir.
Okay. I welcome you. First, I'll just Mr. Sudhir sir,
Sir,
Sudhir sir and Madhurima
thank
madam.
you, sir.
Okay. I welcome you for this session, madam.
Thank you, sir.
Madam, we'll introduce your profile and then we can start. Madam, start.
Good morning to all dignitaries, resource persons, participants from various institutions. I feel privileged to extend my warm welcome to all presented here for second day of short-term training program on emerging technologies in electronics and communication engineering. I, K. Kamartaj, on behalf of ECE Department, SVEC heartily welcomes Dr. K. Sudhir, Professor and HOD of EEE Department, SVCE. Dr. K. Sudhir is having a vast experience in the field of power electronics, artificial intelligence, and Internet of Things and nanoscale structure, VLSI design, and so on. He has 13 years of teaching experience and has published more than 25 international journals, reviewer for 20 plus international reputed journals, received Outstanding Renewal Award from International Journal of Sustainable Energy Technologies and Assessments, elsewhere Scopus Index Journal, and have received Best Paper Award in various international conferences organized by IEEE and Springer. He is NI-CLAD certified professional and authorized trainer of LabVIEW 2019. He is acting as editorial member 5 plus journals like the Journal of Computing and Artificial Intelligence. I also take privilege to invite Mrs. V. Madhurima, Associate Professor, Department of ECE, SVEC. She is Certified Associate Developer, National Instrument. She is also in charge of NI Academy, SVEC. Now, I would hand over the further proceeding to Dr. K. Sudhir. Thank you, sir.
Thank you. Thank you, ma'am. Thanks for inviting. And thanks for Chandrasekhar sir being inviting me as a resource person.
Thank you, sir.
And first of all, I would like to say good morning to all the participants join this LabVIEW and its application second day session. So before getting into the picture, I want to give you the clarity that uh, I'm pretty much feeling a pleasure kind of thing because I'm being introducing this LabVIEW, which is a powerful tool in the world at present. And it's a worthwhile to learn as well as implement in real-time applications. So we may have lots of softwares like MATLAB and PSCAD. You have lot more simulation tools are available, but LabVIEW has become the leading role in industries as well as research purpose. The main we will when you are going to get into the presentation, you will understand what is its advantages and various areas of applications. Then you can understand why it is being in the industry at #1 position. So let me take you to the today's session. So we will start with the, so as everyone is new to this LabVIEW environment, so we have many more simulation tools. So it's a peculiar kind of simulation tool as well as a testing tool, which has advantages of you can see the real-time view of your what's simulation, how it is happening, and what outcomes have been developed from your particular research or your testing kind of thing. So in my session, so first we are going to discuss about what is your LabVIEW and what are the various areas of applications, and then I'll take you to the I'll browse you to the LabVIEW environment, how to get a good hands-on in it by going through the data types, structures, and what are the different palettes and this you have in LabVIEW. So the most important point of thing is the applications of this LabVIEW. That's we are going to discuss about after introducing our data types, structures, and different palettes available in LabVIEW. So first, we'll see what is a LabVIEW. So here you can see my screen that LabVIEW have been abbreviated as Laboratory Virtual Instrument.
So sorry to disturb you. So Sudhir sir, you just give that screen, sir. Screen is not
No,
good.
I will, 1 minute.
Please, please.
Sorry, sir.
Yes, sir. Sir. ఎందుకు సార్ ఏమంటుంది సార్?
Yes, sir. Yes, sir. Screen is now coming. Okay.
Yeah, sorry for that. Sorry for the inconvenience. Let's.
రేపు పోతా ఉంది నాది.
Yeah, I'm talking about first we will be learning about the environment, and then we will go for application of lab,
ఏంటండి?
because we need to get into the application which will be really useful for our real time. So first, what is a lab view? Lab view is a laboratory virtual instrument engineering workbench. I can say like it's a workbench where you are going to design virtual instruments. So what is a virtual instrument? For example, you have a thermometer. So physically you are taking it and testing it for a particular purpose, measuring the temperature. So in a similar kind of thing, in lab view, you will have that visualize real physical object, whatever maybe it is. So that same image will be available in your lab view, and you can sense, that is, you can feel that it is a real object, but physically it does not exist. So we can say it's virtually, your eyes can visualize that. So that's why we will call it as virtual instrumentation laboratory for engineering applications. So you can remember this particular tool as a particular engineering application oriented laboratory where you have virtual instruments. So like for example, you want to measure a speed, you want to measure a temperature, what you are doing in your lab, you are taking that virtual instrument pallets, we will call it as a pallets here, rating. What will happen? Obviously, it causes certain damage to your equipment. So then what is the alternative way? So your simulation softwares are the best alternative ways, and that too, this lab view is more advantageous where you have the same physical look in this particular lab view environment. So that is the main advantage of your lab view. So I can say lab view is used in real time for testing purpose, validation purpose, and monitoring purpose. So you have other simulation softwares. I don't want to take their names. So you have very powerful tools also there. But the problem is, they will be there. You are going to give the parameters and you are going to set the inputs. So for peculiar inputs, we are observing how that particular system is giving the outputs. That only you can observe. But this lab view, once if you design this particular simulation or pallet structure, virtual instruments, it directly connects your real-time equipment, and it automatically controls that equipment, and whenever you need any changes in that, so you can perform the changes and you can work out with that machine. But in ordinary simulation softwares, where you have only you can observe for a particular voltage this much speed you are getting. So you can observe only what for a particular output or particular input, what output you are getting. So only that kind of analysis you can do in other simulation softwares. But this lab view, it directly interacts with all the devices, and it provides a feasibility to the engineer to make changes with it, and we can work out in real time itself directly. Okay. So before getting into the topic, I want to highlight these 3 points. So these three. So that is rather than textual language, here in LabVIEW, we will have a physical palettes. Like you will have a symbols where you can drag and drop and you can connect with vibes. So that is the main advantage of this LabVIEW. Next point, I would like to make you to remind, that is, in this, you should remember only one point. When you are simulating a particular design, you should be primarily focus on whether you have applied or whether you have supplied all the required inputs or not. If you miss any single input in the whole design, so it will never run. So that is the main point we need to remember, because solving the errors is the main problem in all the simulation softwares. So that's why I just request you to remember this particular third point. Okay. And next, whatever program or design or logic or whatever may be your virtual, whatever may be your particular kind of machine you are designing, that particular
screen is not visible. Okay.
So that particular thing which you have designed is called virtual instrument. So for example, I opened a box and I am creating one particular design. That total design which you are saving with particular name, that can be used as a one virtual instrument. For example, I am designing a calculator, I am designing a temperature meter, I am designing a speed sensor, I'm designing a monitoring equipment. So that will be exist as a virtual instrument in this lab. You can yourself you can design. For example, you have taken a bike. In a bike, you have engine, you have tires, you have a controlling part. So your tire can be designed as a one virtual instrument, like where you have friction, everything, retardation, everything. You can mention these parameters in the particular virtual instrument, and you can design an engine with mathematical equation. You can design the controlling clock of your bicycle as a one particular virtual instrument. By connecting all these together, it appears like your front end will appears like a bike, and back end it really works like your physical bike. So that is how we are proceeding in this virtual instruments in lab. So just quickly, I'll just show you with slides, and then we will, directly we will go to the hands-on, because LabVIEW, learning of LabVIEW itself, it takes days and weeks. Okay, so available the available time, we are promising you that wherever whatever the application you are taking, surely all the things which we discussed in today's session will be completely 80% it will be useful for you. Okay, so this is the front end whenever you are opening a LabVIEW software. So currently it is whatever software with us is 2018. Recently they released 2019 with additional features also for research purpose. So 2018 is also having 98% of all the applications as your 2019 software. Okay, so this is how your front end looks in LabVIEW. So in LabVIEW, once if you're getting into the front end page, after that you will be seeing two panels. One is called as front panel, another one is called as block diagram. Okay, we will just these two slides. After that, I will take you to the hands-on session. Okay, so front panel, because you need to understand this nomenclature of this particular LabVIEW. Okay, this terminology is very important. Don't worry about the terminology. We can by ending up this session, you will be very much familiar with all these terminologies. Okay, so just remember, here you have a front panel and block diagram always visible on your screen. So front panel, what is a front panel means? It will be useful for end user, and block diagram is used for engineers. Engineers means the programmers or coders like us. Okay, what we are doing is in block diagram we are designing the code or program which reflects in your front panel, which will be visible for your end user. For example, my manager requires particular monitoring values daily basis. So I'm going to share this front panel with him, and I'll keep this block diagram with me where I design. So whatever the requirement he says, for example, at the left the bottom corner he requires the frequency. At top right corner he requires the graph display. So as per his requirement, we can adjust this in front panel. So we can provide this for end user. So this is about your front panel and block diagram. So apart from these two terms, there are two more terms which are more useful. Without this, we cannot do anything. I can say that these two terms are these additional two terms, that is controls and indicators. I'll use the word controls and indicators always throughout the session. Because here in LabVIEW we will call it inputs, we will call it as a controls, outputs we will call it as a indicators. Okay, don't get confused with that. Just keep in mind that when I'm saying controls, it means that it is an input. I'm taking an input. For example, you ask me add a plus b, then I need to take a, b as inputs. What I'll say is uh, 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 participants, here I'm taking the two controls, and you ask me to display one output. Then I'll say like participants, as the requirement is two controls and one indicator. I'm taking two controls and one indicator. It means that you need to understand that I'm taking two inputs and one output. Okay, so these are the four terms which you have to remember throughout my session. That is front panel, block diagram, controls, and indicators. Okay, let's get into the okay. So this is the front view. Hope everybody seeing my screen, right? If it is not, please let me know. Okay. So this is our the when you open your lab view. Okay. See, you can type here NI. If it is already installed, you can see this NI lab view 2018. Different types of versions are available. 17, 18, 19. Okay. Otherwise, you can directly. It may be a shortcut available on your screen like this. Like this, a shortcut is available on screen, or you can browse from this search bar. Okay. So anyway, by clicking this, you're going to enter into this front page. So when you are designing very big projects, like for example, I want to design a complete model of an industry. What industry consists? Industry consists machines, control boards, and monitoring equipment, security equipment, and access for the people. So everything we have a different modules you have in an industry. So every module has to be created and they have to be interlinked. Then only we can say that I designed the model of the particular industry. So if you are designing such kind of big projects, you have to use this create project, and you are creating each module within the same project. Under the same project, you are creating the module 1, module 2, module 3, and then you are interlinking. The whole thing will resembles like a one single industry. Okay, but that is the higher level. So first we need to go for the beginning. Okay, so first we need to open, as I said, front panel and block diagram, how they will be visible. So here there are two ways. One is control, you go to the file and new VI. I said everything which you are designing, it has to be termed as virtual instrument. Virtual instrument. So that's why always here we will see whatever we are opening a front panel or block diagram, that is called a VI. I'm designing one VI. For example, arithmetic operation means